A bridge over a two-lane road is supported by a semi-elliptical archway that has a height of 20 feet and a width of 50 feet. Can a truck that is 14 feet tall and 10 feet wide drive under the archway without going into the other lane? All right, so there's a little bit going on here, and I think a picture is going to help us. But one of the things we're going to have to remember is that this is a two-lane road. So our truck's only allowed to occupy one side at a time. But let's go on and get a picture of the bridge going. So I have a bridge over a road, but the archway under it is in the shape of half of an ellipse. And so that's what semi-elliptical there means. And so my road, I'm going to think about going under the bridge. So it's like could go this way or that way in that two-lane road. So one direction kind of going into the board, one direction kind of going out of the board. All right, and let's see, what else do we know? We know that the width is 50 feet. And that the height here is 20 feet. And when I look at this semi-ellipse, what I realize is that 50 feet here is the length of the major axis. So half of that is the value of A. So A is going to be 25 feet. Here I have half the length of the minor axis. Well, I know this one's the major axis because it's longer, right? 25 is more than that distance 20. One way to think about this value is that is the semi-minor axis's length, right? It's half of it. Just like I could say the semi-major axis has a length of 25 feet. Well, from here, I could actually write down an equation for this elliptical archway. X squared over a squared plus y squared over b squared, because very secretly I am just thinking that, well, I could put the origin right at the center of the ellipse. There's no reason not to, making that an x-axis and a y-axis. All right, so I wanted that equation so that we could actually address the question. Can a truck that is 14 feet tall and 10 feet wide drive under the archway without going into the other lane? If I think about that truck being 10 feet wide, and just imagine that it's just barely on the center line. So the rest of the truck's right there. The question is 14 feet too tall, right? Is the archway taller than the truck? So I got 10 and 14, and maybe the truck's too tall, right? Maybe 14 feet would be all the way up there and it would hit the bridge, and that would be terrible. So what I'm going to do is find the height of the arch here at x equals 10 feet. Thinking about that as the point 10 comma whatever it is. All right, so I'm gonna plug 10 in for x and we're gonna find y. And then the question really is that y value higher than 14? If that y value is more than 14, then our truck will fit. All right, so we plug in a 10 and we get 100 over 25 squared plus y squared over 20 squared is equal to 1. And we need to get y by itself. So let's just go on and say that's going to be y squared over 400, right, that 20 squared. And then let's take this away from both sides. So 1 minus 100 over 25 squared is 625. All right, so I have 1 minus 100 over 625. Excuse me, 0.84, but I prefer improper fractions. So y squared over 400 is equal to 21/25. Multiply both sides by 400. And I get that y squared is equal to 336. And to find a value for y, we can just take a square root. And if our truck's going to fit, I need this number to be more than 14. Well, the square root of 336 is 18.3 feet. And there I've been safe anyway, and I've rounded down. It's appropriate to round that way anyway, because it's an 18.33, but rounding down, I'm not going to run the risk of accidentally hitting the bridge. And it turns out that 14 feet, the height of the truck, is less than that, so the truck will fit. Without having to go into the other lane. And that's it.